Now, section 4.3, example 3, is a case of pointing out that actually, so we know what the answers to some of these definite integrals are without taking limits, because we just recognize the figures and we know some geometry. So for instance, in their example 3a, they're looking at the integral from 1 to 3 of 4 dx. Well, a picture of that then is, here's 1, here's 3. So we've got the area bounded by the x-axis, these two vertical lines, and then our function, f of x, is the constant 4. And so it's that area, but that's a rectangle. And that's a rectangle of width 2 and height 4. And so this definite integral is equal to 8, 4 times 2. Okay, so now we could have done limits and all that, and this one has one big rectangle. It's sort of silly to do all that, but now let's take a trapezoid, and so in this case they have in B, they want the integral from 0 to 3 of x plus 2 dx. And again, well, I draw the picture. So this is 0, this is 3. Now x plus 2, it starts off here at 2, and it goes with a slope of 1. And so by the time I get up here, this is 5. And so this definite integral is asking about that area. It can be interpreted that way. And so this is a trapezoid. And you may or may not know the formula for a trapezoid. If you didn't know the formula for a trapezoid, well, you can kind of get there by, I've got a rectangle here and a triangle. But for a trapezoid, it is just the average height here. So we have 2 plus 5 over 2, and then times the width, so times 3. And so that's 7 over 2 times 3, so 7 over 2 times 3, which is 21 over 2, or 10.5. Okay, and so there we have evaluated that definite integral without using limits or anything like that, because we realize we can interpret it as area, and therefore we can just use our knowledge of geometric figures. And then C is from minus 2 to 2 of the square root of 4 minus x squared dx. Now, so this is y equals the square root of 4 minus x squared. Well, if I square both sides, this is y squared equals 4 minus x squared. Add the x squared to both sides, and I get x squared plus y squared equals 4. Oh, that's a circle of radius 2 centered at the origin. But it's, since we have this, it's just the top half. And so, there's minus 2, there's 2. We want that area, but that area is just half the area of the circle. Well, the area of the circle here is pi r squared. So then this area, our definite integral, is equal to our pi times 2 squared, because that's the radius, and then over 2, because we just have the top half, and so we get 2 pi for our area there. Okay, so that's example 3 is a really nice example of being able to just, if we know certain figures, then we can get those definite integrals without doing all the limit stuff. Okay, so we'll end that one there.